we will be charging and discharging capacitors. Charging and discharging capacitors. Now, see, if this is a capacitor, oh, I have a lamp connected here. Battery is connected here.
Excuse me, sir, your screen is not being shared.
Thank you for letting me know. Just 1 second. So we are charging and discharging capacitors. In here we have a circuit. In the circuit we have a capacitor connected to a battery. There is an ammeter. There is this double switch. This is position A, this is
Sir?
position B. Yep.
Will we do properties of capacitors in parallel?
Oh, we have to do that as well. Okay, we can do it after this
आपने
one.
सीरीज कर लिया था तो मैंने क्या पैरेलल कर लेते हैं वो साथ साथ हो जाएंगे.
Acha. So very quickly we now be doing capacitors in parallel. Actually, we left it from yesterday. We were supposed to do it over there, but we couldn't. So let's do it now. There is a capacitor number 1. There's a capacitor number 2. There's a capacitor number 3. So there can be multiple capacitors connected. In parallel. So there is a potential difference of V provided over here, EMF of V. This is a junction. So this is capacitor with capacitor C1. This is capacitor with capacitor C2. This is capacitor with capacitor C3. What will be same for all 3 capacitors? Answer is potential difference. They all will be getting same potential difference. What will be different for these capacitors? Answer is current or charge. You know why? because every capacitor has its own capacitance. So different kind of charge will flowing through. The capacitor that has more capacitance will have more charge. The one that has less capacitance will have less charge. So there will be charge Q1 on the first one, Q2 on the second one, Q3 on the third one. Q1, Q2, Q3 means three different charges depending on three different capacitances, C1, C2, and C3. Now, what do we know? What charge has come from the battery? Answer is Q. And then the charge splits into Q1 and Q2 and Q3. So properties of parallel capacitors. Just one second. Properties of parallel capacitors. Number one, all capacitors get same potential difference as EMF of battery in the diagram on the right. So if there is no other capacitors, just these three capacitors connected across the potential difference, then they all will get the same potential difference as the potential difference of the battery or EMF of the battery. Now, charge splits larger capacitor gets more charge. So the one that has more capacitance will have more charge. So Q equals to Q1 plus Q2 plus Q3, where Q equals to total capacitance into total voltage. Q1 will be capacitance of 1 into voltage. Q2 will be capacitance of 2 into voltage, and Q3 will be capacitance of 3 into voltage. So let's put all these values of Q over here. We'll get total capacitance into voltage equals to capacitance of 1 into voltage, capacitance of 2 into voltage, plus capacitance of 3 into voltage. I hope you can see that I can easily take V as common, C1 plus C2 plus C3. There is V on both sides, so I can cancel them with one another, making total capacitance equals to C1 plus C2 plus C3. So if we connect capacitors in series, we have to add the reciprocals to get the reciprocal of total effective capacitance. But if we connect capacitors in parallel, simply add the capacitances of each capacitor connected in parallel. This is the total effective capacitance of all the capacitors connected in parallel. Now, 4 n capacitors of capacitance C connected in parallel their total effective capacitance CT will be simply CT equals to C plus C plus C plus C plus C plus C. Like there will be n C's that we will be adding. So we will get n into C. So if there are 10 capacitors, each of capacitance 20 microfarad, and 10 of them are connected in parallel, the total capacitance will be 10 into 2, 10 into 20, 200 microfarad. Now, so now we have total capacitance. What else? Nothing. Let's practice. Question. Calculate total effective capacitance in each circuit. All capacitors in all circuits have a capacitance of 600 microfarad. So all capacitors that I will be making in all of the questions over here, they all have a capacitance of 600 microfarad. So first, okay, you can copy the diagram and start solving it right now. Mm, Okay, you can copy the diagrams and start calculating.
Sir, is answer number 4 दिखा सकते हैं, please? Okay, thank you.
Okay, I hope you're doing it right now.